Okay, first I want to do exponents and fractions. I'll give you a couple of examples. The directions here say evaluate, and then you have to put it in simplest form. Okay, so my first example, I'm going to work 4/3 to the third. So the 4/3 inside the parentheses is what we call the base, and the 3, the small raised 3, is either the power or the exponent. And this guy tells you how many times to use the base as a factor. And factors just things that we multiply together. So this 4/3 to the third is saying to take 4/3 times 4/3 times 4/3. When we multiply fractions together, we multiply the numerators. 4 times 4 is 16. 16 times 4 is 64. And then we multiply the denominators. 3 times 3 is 9. 9 times 3 is 27. And then we check to see if these have a common factor. Is there something that goes into 64 that also goes into 27? In this case, no. And so there's our final answer. Let's look at a second problem. Suppose that we had 5/4 to the second power, or 5/4 squared. So this means 5/4 times 5/4. And once again, when we multiply fractions, we multiply the numerators. 5 times 5 is 25. And then we multiply the denominators. 4 times 4 is 16. And we look to see if they have a common factor. We know they're not going to, because 5 and 4 didn't have a common factor. So this will be as simple as those are going to get. Okay? I'd also like to take this a little bit more into the Pythagorean theorem. The Pythagorean theorem says that a squared plus b squared is equal to c squared, where a and b are legs and c is the hypotenuse of a right triangle. Okay, so you're talking about right triangles. It has to have a right angle. So remember the symbol to show a right angle. If you have a ray to show a right angle, you'll see that right angle box in the corner. So if I'm looking at a right triangle, let's just talk about the pieces. So here's my little right triangle. Okay. The legs connect to make the right angle. So I have a leg here and a leg here. They connect to make the right angle. And then the side that is connects the two legs together, that is the hypotenuse. It's also the longest side of a right triangle. So let's try to solve a problem where we have a missing measure. Okay, so our first example, I'm going to have a triangle, and I know it's a right triangle, okay, because of the right angle, and I don't know this side, but I know this leg and the hypotenuse. Okay, so if I'm going to use the Pythagorean theorem, I know a squared plus b squared equals c squared. So a and b, remember, are the legs, and c is the hypotenuse, and so I'm going to substitute those in. Remember, the two legs make the right angle, so this is a leg and this is a leg, and the a and b don't really matter. They're just the legs, either one. And then my hypotenuse is over here at the 5. So I would get x squared plus 4 squared equals 5 squared. And then I know about exponents, so I'm going to go ahead and simplify. I don't know x, so I leave x squared plus 4 squared is 4 times 4, which is 16, and 5 squared is 5 times 5, which is 25. So just like solving a regular equation, I have to get the variable by itself. So here I'll subtract 16 from both sides. And so I get x squared is equal to 25 minus 16, which is 9. So I don't really care what x squared is. See, this problem is asking me for x. So I have to, I call it undo. Okay, so I have to undo the square, and I undo the square with a square root. So I would take the square root of both sides, and so that'll give me x, and x is equal to the square root of 9. So the square root and squares, they're related. So to find out what x is, I take the square root of 9. So my question is, what times itself is 9? And it's 3. So the square root of 9 is 3. So that means that this side over here was 3. Okay, let's try another one, another Pythagorean theorem. Okay, so this will be my second example. So again, I'm going to have a right triangle, and I know that this side is 8, this side is 15, and I'm looking for that side. So first of all, label them so you know who's who. Remember, the two legs make the right angle, so this is a leg and this is a leg, and so the other side is the hypotenuse. So my formula, a squared plus b squared equals c squared. Remember, these are my legs and this is my hypotenuse. So I'm going to substitute my values in. So it doesn't matter where I put the 8, I can put it here or here. So I'll say 8 squared plus 15 squared equals c squared, or actually I should put an x there, x squared. So 8 squared is 64, 15 squared, that's 15 times 15, that's 225, equals x squared. So now I'll add these together, and so that's going to give me 289 is equal to x squared. So just like before, I don't want to know x squared. What do I want to know? X. So I have to take the square root. So on my calculator, I can use the square root button, and when I use the square root button on my calculator, the square root of 289 is 17.